In the freezing point depression lab, you could have three group members put their names. This was a guess. His first question: what are important factors to making ice cream from milk? But honestly, the important factors are the type of milk you're using, how much ice you have, how much salt you have, and if you're adding flavors or not. So the pre-lab, this is just to tell me if you did it by one person doing all. This say number two is to discuss with your parents, and you must make sure that was okay. So that's my waiver, so I don't get in trouble. Pre-lab question: how much ice do you think you'll need to freeze 1 cup of milk? You basically need 3 times the volume of ice to freeze 1 cup of milk. So if you have a lot of milk, it will not freeze. It's a 3-to-1 ratio. Why are we using salt? Salt depresses the temperature of ice, lowering the freezing point. So when you have ice at 0 degrees, by adding salt, it makes the temperature of the ice go down even lower to -5, -10. And this will make the milk freeze because the milk's freezing point is about 2. Why can't we use Diet Pepsi and make Slurpees? Diet Pepsi is a liquid, and with the ingredients inside the liquid, it's very difficult to freeze it because those ingredients absorb heat. So if it was just water, maybe we could freeze the water. But you add the artificial flavors and the sodium and the potassium and all the different minerals, and that depresses the freezing point of Diet Pepsi to even lower than 0. And so it will not freeze using our ice. It will be very difficult. So that's why we use milk. That's why when you see a slurping machine, it is constant. It always turns, always turns, always turns, because it has to turn in order for you to see to have contact with the cold part of the machine. Now in this, assuming number one, they should be all liquid here in step one. Step two, it should feel like liquid. Step three, when you add the ice with the salt, it should feel pretty cold. After you shake for 1 minute, you may or may not see any results. So normally it happens about 5 to 6 minutes where you start to see the solid forming within the milk. So that's what I should see in your lab observations on how the bag feels. There should be a picture of the milk before experiment and a picture of the milk after. So what happens shortly after you added the salt to the ice cubes, the ice gets really cold. You start seeing the salt kind of eating into the ice as the salt crystals absorb the heat and starts to melt the ice. And the temperature should be below the freezing temperature for water. So that's a question that you should know based on all the PowerPoints. Number two, was the only factor that could have caused the changes shown in question number one. What does this tell you about the freezing point temperature of salt water compared to fresh water? Since salt lowers the temperature of normal ice, the freezing point of salt water should be lower than the freezing point of fresh water. Number three, heat energy is needed to change the phase from solid to liquid. List the possible sources of heat needed for this phase change in your baggie. It's a very poorly written question, okay? And so from solid to liquid, the heat energy could come from your hands. It could come from the ambient heat around you, like the sunlight or the room temperature, the air around you being hot also. And the question is, the best possibility would probably be the air around you being warm. Number four is inside this paragraph, unfortunately. In looking at the temperature changes shown on your data table, explain how the energy flow of the baggie system resulted in your tasty treat for an end product. Where is the energy flowing from and where is it going? So the energy is flowing from the liquid as heat energy out into the ice, converting the ice to water. But it's a system. So as the heat leaves the milk to become solid, that heat goes to the solid ice and making that into liquid. What state of matter was the milk when you began? It should be liquid. Number five, what state of matter was the milk when you finished? It should be solid or semi-solid, solid and liquid. In order to change the phase of milk, what had to be removed? The heat energy in the liquid milk. What happened to the heat energy that left the milk? As we talked about earlier, the heat energy for the milk going from liquid to solid is transferred to the solid ice, and the solid ice therefore goes from heat solid to liquid. It's always a closed system. This is called conservation of energy. If you did not add the flavoring, would the ice cream have frozen faster? Yes. The flavoring adds another dimension to the milk and adds more molecules that absorb heat. So milk by itself freezes really quickly, but by adding more flavors like sugars and chocolate syrup and other molecules that are bigger than water or bigger than milk, then what happens is this absorbs more energy and takes more energy, more ice to absorb the heat coming off the liquid. Why did the outside of the bag get wet? When you have a temperature differential between the solid ice and the air outside, you have condensation forming on the bag. So the air outside the bag starts to lose heat energy and goes from gas to liquid. It's just like the system we talked about before with the milk going from liquid to solid and the heat energy going to the ice, turning the ice from solid to liquid. In this situation, you have the heat energy also from the ice going to liquid, transferring to the air outside. And what happens is the air loses heat energy and goes down and becomes a liquid.